Chapter 1 Introduction Part 2. Becoming familiar with your programming environment. The programming environment can also be called an IDE for Integrated Development Environment. And that means that we can write our programs, we can debug or find errors in our programs, and we can compile and run our programs all in the same environment, which these days virtually every development environment is an IDE, but back in the old days, they were all separate programs. So that's what the whole meaning behind integrated. They can do all of it. The IDE that we will be using is called NetBeans, and there will be a separate video on how to become familiar with NetBeans. But know that every IDE contains an editor to allow you to edit your code and to modify your code. Know that Java is case sensitive. That means an uppercase letter is different from a lowercase letter. And that's something that trips up a lot of beginning programmers, is that case matters. It's really important that you type it exactly when you're copying code. The Java compiler translates the source code into class files. So when you're typing up your program, that's what's called source code, and that is contained in a file with a .java file extension. So the file name will always have .java after it. When the compiler translates your source code, that .java file, into a language that the computer can understand, that means a human can no longer understand it. The computers can understand it, but not the human. So that file, that your source code translated into object code or byte code that the computer can understand, that's in what's known as a class file. It has a file extension of .class. It is not human readable. So when you want to work on your files, you want to share them with me, you have to use the .java file, not the .class file. The class file contains instructions for the Java virtual machine. So the way Java works is that it's got a little piece of software known as a virtual machine that actually runs the byte code. It doesn't run it natively on the computer. It's a subtle distinction, but it's what gives it the platform independence. So that Java virtual machine is what allows Java to be platform independent. That's what's important to remember. In our programming environment, we're going to start with a simple, we're going to start with our Java development environment. And again, there'll be a separate video specifically for NetBeans. We're going to write a simple program, we're going to run the program, and then we're going to talk about organization. So here is an example of a development environment, an integrated development environment. This is not NetBeans, but it's substantially similar. So note that the files where the files that make up your project or your application are on the left-hand side. It's under that package tab, and NetBeans works exactly the same way. And then on the right-hand side, you've got hello printer.java. Do you see that, where that tab exists? That's your source code. That's your window where you're typing up your source code, and NetBeans works exactly the same way. It's going to have that there. And then down at the bottom is your console output. So basically two different types of programs, and one is a console program that will produce output and receive input from what's known as the console window, it's just a little text window. And the other type of programs are GUI programs, graphical user interface programs, and those are the ones that you're probably familiar with using because those are most ubiquitous. The console programs are easier to write, and so we're going to start with console and then make our way over to the GUI programs. But the output from this particular program, you look at the source code where it says Java program and it's got a little arrow, that is what the programmer typed up. And then down here at the bottom where it says program output, that's the output produced by that program. Notice also in this figure where it says click to compile and run, similarly in NetBeans there will be a green triangle that you click to compile and run the program. So when it compiles, the integrated development environment goes through and makes sure there's no mistakes. It can translate every bit of code into a language that the computer can understand, and then it will run it on the computer to produce, in this case, to produce the output, hello world. Here's another example of a console window. We are not going to get into, notice it says terminal at the top, we are not going to get into using terminal in this class, but we will be producing output that you can see in the output window similar to the last graphic. Here is a schematic of what it takes to create a program. So the editor is where the programmer, that's you, will type up your source code or your source file. You'll send it to the compiler by clicking that green button. The compiler will make sure there's no mistakes and produce a class file. Working together with library files, that's code already written by some nice folks at Sun Microsystems or Oracle. Working together with those, it will be run on the virtual machine, which will produce a running program, such as the output you saw previously that said hello world. So that's basically the format that happens. It starts with the editor, where you type up your source code, you hit the green button, the compiler translates it into a class file, joins it with the library files, and runs it on the virtual machine. The only part that the human is involved in at this point is those first 3 steps. The editor is typing up the source file and then hitting the compile button. Here's what a folder hierarchy looks like, and some of you may have more experience than others on working with folders and getting organized with your files on your computer. Hopefully in this class you'll have an opportunity to even get more in depth with how file systems work. But just briefly, in this folder hierarchy, look at the top where it says ch01. That's a folder that contains some other folders. Other folders contained in ch01 are section 4, section 5, and section 6. Section 4 contains a file called helloprinter.java. Section 5 contains a file called printtester.java. And section 6 contains error1.java, error2.java, error3.java. So all of those individual files are in folders which are in the overall folder of ch01. Similarly for ch02. So here is our first program that will be displayed in NetBeans. You will get those line numbers on the left-hand side. They do not affect the running of the program in Java, in Java, but they do help the programmer. So I can say, look at line 5. So right now, look at line 5. It's got the 5 next to it, and it starts with // display a greeting in the console window. That's what's known as a comment. Java ignores comments, and they're only there to tell the programmer a little bit about what's going on. So that's just saying, hey, this is what's going to happen. We're going to display a greeting. It doesn't cause the greeting to be displayed. That's the line that follows. Notice the comment starts with a // It's on the same key as the question mark. You might look at your keyboard now and try to find that. And it ends with when the programmer types the enter key. So it ends at the end of the line. Begins with a // and ends with the end of the line. Let's look at the rest of the code in detail. We're going to analyze this first program. Classes are the fundamental building blocks of Java programs. So our class declaration starts with public class hello printer. So let me back up a second. See that at line 1, public class hello printer. Notice the name hello printer. It's black. That means that the user made it up, the programmer made it up. It starts with an uppercase letter, an uppercase H. That just is a convention that we use, a style that we use for class names. They should start with an uppercase letter. Also, because this is 2 words, we don't have a space between the words. Spaces aren't allowed. However, the first letter of the second word is similarly capitalized to make it easier to read. We call that camel casing. So hello printer is the name of the class, and the programmer made up that name. In Java, every source file can contain at most 1 public class. So you've got to have a class in there. And the name of the file must match the name of the class. So our class name is hello printer. The file it's contained in is helloprinter.java. And NetBeans takes care of that automatically for you, so you never have to worry about that. However, some beginning programmers will go in and try to modify the class name, and that's where you get into trouble, because then it will be different from the file name it's contained in. Every class contains declarations of methods. So every class contains what's known as methods, and each method contains a sequence of instructions. The starting point, the single entry point where every Java program starts is the main method. So the method that's named main contains the first instructions that get run. And let's go back just a second so you can see it. Whoops. So look at line 3. Public static void main string with square brackets args. When we start writing our programs in NetBeans, this will be produced for you. You don't have to memorize it, but I just want to point out the word main. That means, yo, Java, this is where you're going to start. Here's the starting point. Every single Java program starts at the main method. In the parentheses after main, you may have noticed it said string square bracket args. We don't need to worry about that. That's beyond the scope of this class. However, I do want to tell you that the stuff in parentheses is called an argument. So when we put stuff in parentheses there after a method name, such as main, we are specifying arguments. So every Java application contains a class with a main method. The main method includes the instructions where the program is going to start. And here's an example of declaring a main method. Notice after the public static void main string args, there's an open brace. Look at your keyboard right now and try to find that open brace. You have to hold down the shift key to get it. It should be right next to the P on the keyboard. Following a method header, such as public static void main string args, you will need to have an open brace that says, yo, this is the beginning of this method body. It's the beginning of the statements that belong to this method. Similarly, there is a close brace down at the bottom. So in this example on the slide, the dot, dot, dot just indicate that's where the statements will go, whatever they are. But we do need an open brace and a closed brace to put around those statements so we know which statements belong to this method. Also, notice how the open brace and the closed brace line up. They should be in the same column beginning right underneath the P in public. That's just a point of style. It makes your code easier to read. I'm a real stickler for lining up those braces, so make sure that you get in the habit of putting the open brace right underneath the P in public and the closed brace in the same column as the open brace. The body of the method is the statements, what appears inside those braces. Our program, our first program as shown on the previous slide, has only one statement, and it is system.out.println, and then in parentheses and in double quotes, hello world. It produces a line of text, hello world, in the console output window. Hello world is traditional. It is the first writing a program that produces hello world is the first program that people write. So when you do this, you are joining the great fraternity and sorority of programmers throughout history, and that's really a moment. That's something to be proud of. The method call, when you're telling a method, hey, go run, it is an example is as follows. System.out.println hello world. Remember we talked briefly about those library files? The nice folks at Sun Microsystems wrote a method called println that is part of system.out that will cause this output to be produced in the output window. We do not need to know how it works. We don't know how println works, we just know that it works. We know we put something in parentheses, it's going to go in the output window. And that's really the beauty of programming. We can reuse stuff that other people have used without having to know how it works. Some of you might be driving, and if you're driving, I ask you, do you know how an internal combustion engine works? Do you know how your car works? Maybe you don't have an internal combustion engine. Maybe you've got an electric engine. Do you know how it works? Most of us don't. I don't know how a car engine works, but yet I can drive a car. I've been doing it for a long time. So similarly with methods in Java, you don't need to know how they work. You just need to know it's going to work. This method call, if we want to run println, we've got to provide a method call in the manner it expects. So we start with system.out.println, and then in parentheses, we put something. We put some arguments. In this case, our argument is hello world in double quotes. So here's an example. Public class hello printer. Every Java program has, every Java file has at least one class, and then we've got an open brace and a closed brace to denote the beginning and the end of that class. And inside this class, we've got a main method, public static void main string args, similarly with the open brace and the closed brace to denote the body of that method. So just like we've got the braces for the body of the class, we've got the braces for the body of the method. And inside there, we've got a method call to the system.out.println method. Be sure that you have your opening and closing braces that match. Notice how they are lined up. Also notice how inside those braces the statements are indented. This makes it easier for others to read your code. Use the tab key when you are indenting your statements. It just makes it a lot easier. Do not use the space bar. That is going to make life more difficult. Trust me on this one. Use the tab key. It'll make it easier to get everything to line up. Also notice, we haven't mentioned this yet, that every statement ends with a semicolon. So system.out.println, that method call that's going to produce our output, we've got a semicolon at the end. We do not have a semicolon at the end of the class declaration or the method header, just at the end of the statement. If all this seems overwhelming to you right now, hang in there. It is overwhelming at first because it's all complete Greek. But if you hang in there and you keep reading the book, and practicing and watching the lecture files, paying attention in class, it will all become clear. And by the end of, say, October, you'll be looking back at this and going, why did I think that was so confusing? So hang in there. It will become more clear.